Okay, so welcome. I think you can take it from here, Tarek. I did one small change to the agenda from earlier meeting, and that actually I pasted the action item. I think we need to address at this meeting into the agenda. If there are more action items, yeah, just bring them up. But it's kind of my opinion on what we need to say something about.
Yeah, this is okay. Okay, so I have on the three action items on the first bullet on the agenda. So the first one, we are asking for a consensus on the directives that we came up with. I'm flipping to the page where we have the directives that we reviewed last time. I formulated an email, and basically, this is my proposal: is we send an email to the three working groups, or maybe, yeah, I think these are the groups that I thought of, but let me know if I'm missing any. And basically ask.
So Tarek, on the action item, there is TEAS also in line as one of the groups.
Oh, okay. Yeah, I mean,
I'm kind of a little bit ambivalent. I think it would be good to have TEAS joining in if they want to, but we need to check that.
Yeah, we were debating last time is if TEAS wants to engage in this or not. I don't mind adding TEAS in the list.
I think you should send a mail to the TEAS chair and ask them if they are okay with sending out this mail.
Oh, okay. Yeah, sure. That's a good idea. Okay. So the proposal is to send this email to the working groups and ask them for reviewing the text and sounding any concerns and feedback. The text is basically, mostly taken from here, but so I did, I think I did just edits, but I did also, instead of cannot here, I put must not. So I want your feedback on that as well. It's more terminology of IETF. Is that what we're signing on as a must not?
Don't we have cannot in the list?
Do we have still cannot? Do you see it?
No. I was asking about in the requirement language. Don't we have cannot in that list?
In all caps?
Tarek.
Yeah.
I have a question. So on this line, so that must not followed by more than one set of post-stack data. Do we have a definition of what is the set of post-stack data?
That's a good question. There is an elaboration here that is the FAI style PSD. This is one post-stack data. The .NET control word and ASH. I think the ASH is another type, or any other future PSD. Yeah. So how about you read this and let me know, does it address your concern?
Okay. My question is, so are we making this list exhaustive, or these are examples? Because if it's exhaustive, then we will need to do control word or pseudo-wire control word, and then .NET ACH to add to the list.
I think, yeah, I agree. We did not formally define post-stack data in this text. Probably we have it somewhere else, but if you want it to be, generic to capture everything, we may want to, rather than jot examples here, say exactly.
Sorry, Tarek. I think we should take a guilty until proven innocent. And any legacy post-stack data wants to say, I can work with this, should prove that they can work with it. There's a way to be interoperable and backward compatible. Otherwise, we have to say, no, you can't join the new thing. So essentially, if you say the .NET control word is okay, then there has to be a document that says this is how the .NET control word will work with the new post-stack data. The draft that I'm writing for the first Nibble registry generally takes the direction that when you have the new first Nibble directory, the registry, 00 has some meaning, 01 has some meaning, 5 has some meaning, 0406 are set aside for IPv4, IPv6. But we still have several, and we don't need too many because we just want one header that says, this is the new style post-stack data. And so if the first label after the label stack is, let's pick a number, 7, then 7 says, I'm a header for post-stack data in the MEAD world of things. And after this, here is how we lay out things. We might choose TLVs, we might choose next header, we might choose some other mechanism. And that's how that would work. So then you have a choice between any of the existing ones or the new post-stack data, in which case the first nibble is 7, and then we define what the structure is. Then you can pull in a backward compatible, you can pull in functionality from, say, the .NET control word, saying, this is how the .NET control word can fit into this whole schema. So you say the first nibble is 7, and then maybe you have a length field, and then you say, here's how .NET fits in, here's how the new things that we want fit in, here's how generic delivery functions fit in, and we build that. So you can use .NET in the new world, or you can use .NET in the old world, but you can't use both because there are no two first nibbles. There's only one first nibble. Does that make sense?
It makes sense, Kiriti. It's just how to word it in the
exactly.
sentences.
I think we have more than one issue here. So I think we should be generic about post-stack data that can't coexist. And that's the legacy and the file style. They can't coexist.
Yes, exactly.
File style PSD can exist because that is how we will make it. The other question is, should there be a must not, or should it be lower cap? What? Lower case?
File style can coexist with what, Loa? When you said it can coexist.
I say that the legacy that goes into the first 4 bytes after the boss, or even longer if they are, they can't coexist with each other and with the file style.
So I think it would be simpler to just say we now have a first Nibble registry. So whether you have a file style label in the stack or whether it is, there is no FAI label at the stack. When you parse this, at some point you say, I know.
First of all, you're very hard to hear.
Okay, I'm in the car, so it's a bit difficult, but
okay.
In 5.
Let me try to switch away from screen. Hello?
Yeah, better.
Is this
Much
better? Okay,
Yeah, yeah.
okay, okay. So if you have I know we were trying to craft all this about coexistence and non-coexistence. Essentially, what we have is a label stack followed by a first nibble. And the first nibble says what is going on after the label stack. So if you say that first nibble, we have a registry, we have a way of dealing with this, there can only be one first nibble, and that first nibble says what's coming next. So if that first nibble is 0, 0, then it's either a pseudo-wire control word or a detnet control word. And we know how that works, and we don't change that. If the first nibble is 0, 1, there's some definition. I think it's a detnet, whatever, there's some data. If it's 0, 4 or 0, 6, you're expecting an IPv4 or IPv6 packet.
But Kirit, are you talking about the next action item now, or are you talking about getting consensus on the statement we agreed on last time?
So the getting consensus on the statement we agreed last time, the way we were phrasing it, I think there's a cleaner way of phrasing it now that we have this first nibble registry. So okay, to your point, I'm proposing a new statement for this.
Is that really necessary? Doesn't this cover actually what we need?
So what we're doing now is sort of taking case by case. This can go with this cannot go with this. And okay, let me tell you what the proposal is, and then you decide which way you want to go. If I take if I assume the existence of a first nibble registry, the first nibble registry will tell you what the post stack data is. So I parse the label stack. I'm at end of the label stack. I look at the first nibble. If it is a 0, it is either the detnet control word or a
Wait a moment, Karita. You need to pick up a hint from something else in the stack before you're allowed to pass that nibble. You can't just pass the nibble on its own.
Okay.
Because it could be a legacy pseudo-wire that doesn't respect the first nibble.
Actually, and what's the number? 4929? The load sharing one, it actually says that if you are an application that don't want load sharing, you can use 00 or 01 as the first nibble.
But the point is, there are packets in the wild that don't respect any of these rules. So before you're allowed to look at that nibble, you must confirm from the stack that you're allowed to make a decision on that nibble.
I agree. I also have a concern about post-stack data. Does it encompass user data? Like generic user data?
It does, unfortunately, because when I mean, not the post-stack data, the first nibble does. So when the first nibble is
user data only.
But when the first nibble, so if you're doing IPVPN, there is no post-stack data at all, typically. So you have the first nibble is 4. So if you're looking at the first nibble, if you see 4, it could be a number of things, but you probably assume that it's user data.
You cannot make that assumption, though, Kriti, can you?
You can't.
It could be an Ethernet packet.
You can't. Well, so we have problems that, as you said, there are in the wild things that are doing that. There's not much we can do about that.
Well,
What we can say, okay.
What we can do is we can require something in the label stack, either an SPL or a FEC, to tell us that it is safe to look at the first nibble and make any forwarding decision based on it.
Well, I mean, if you're going down that path, we could say that if the first nibble, if the payload is Ethernet, you must put a control word. Now, there'll be legacy applications that don't respect that, but there'll be legacy applications that don't respect what you just said either. So we have to understand that there will be some packets.
No, wait a
I mean,
moment.
you just said there will be a label in the label stack, a special purpose label or something. But there are things in the wild that say there's no such label. There's a pseudowire control. I mean, pseudowire label.
So those things know what they're doing, right? Those things just think the world is like the world was when they were designed. But the new things are going to make decisions based on this first nibble. And before they can make that decision, they need a qualifying decision somewhere in the stack. And those applications
not necessarily in the stack.
Well, it can be. When I say in the stack, it's either got to be, I think, through a FEC or some form of SPL.
It could be the first nibble.
It can't be, because the first nibble could be an Ethernet packet.
No, I'm saying that the first nibble. So if you're mandating new behavior, you say that every non-IPv4, non-IPv6 packet must have a post-stack data. Now, whether this post-stack data is heralded by the control plane or it's heralded by a special purpose label, that's something that we need to decide. But you cannot have, if you mandate that every non-IPv4, IPv6 packet has the post-stack data, you cannot have a first nibble being 4 unless it's IPv4.
So that requires a complete forklift on the network before you can install this feature.
It only requires that for new implementations. I'm not saying we can fix the problem where you have an existing pseudowire without a control word. It happens to start with an OUI whose first nibble is 4. That's reality, and we have to live with that.
Or 7, or it could be anything. It can be any 0 to 16, and 0 to 15 rather.
So the question, Kuriti, in other words, can user data exist after the MPLS label stack, bottom of stack, and start with anything not 0?
Anything not?
Yeah. Are you mandating 0 there? I don't think it's always.
I'm not mandating 0. I'm mandating non-4, non-6 unless it's an IP packet.
Okay, and
right, and that means we have to guarantee that we've upgraded the entire network before it is safe to run this feature.
Yeah, no, I'm just saying that new behavior. We mandate that new implementations do this. If existing implementations do this, they will work as they worked before, including as badly as they worked before, trying to load balance an Ethernet packet thinking it was IPv4. Until those implementations are out, there's nothing we can do about them.
No, but the thing is, if you've got think about a practical situation where you've got, say, a P router somewhere in a provider's domain, and this P router respects the first 4 bits below the stack. That requires that every PE somewhere upstream in some other provider's network feeding traffic that's going to go through that LSP at some point is also upgraded. Otherwise,
I don't see why. No, but I don't see why it requires that. Because
there could be one that isn't inserting a control word, and it's just going to, as an example, and it's just going, and it's still going to be groomed through the network onto that LSP down in some domain downstream, and then be misinterpreted
Indeed.
by this NSR that is assuming that everything is compliant. So you always need some other context information.
So okay, I guess one key thing is the new behavior that we mandate or we suggest. We can choose the words. The new behavior essentially says, for you to be compliant, for the new device to be compliant, these are your rules. And if you do this, you're not going to miss load balance an IPv4, an Ethernet packet thinking it's IPv4. But you're not making any assumptions about others. And if they send you packets, and they haven't put the control word, you yourself might miss load balance them. And if you send very good packets to them, at least they won't be able to miss load balance them because you put your control word on it. So you can't control other behaviors, but you can control your own.
So I think that for your feature, the way you've described it to be working in the network, Kariti, I think you have to do two things. You have to mandate that every single PE in your network is modified to this new behavior, and every carrier.
No. Okay.
Yeah.
No. Okay, go ahead.
Well, if you don't mandate the upgrade of all the PEs, one of them could be running the legacy mode.
Yes.
And that could be sending traffic through that spoofs the behavior you're trying to get in with your Nibble.
Well, I mean,
but wait, you're trying to solve a very big problem, and what we addressed with the design directive is kind of a much smaller problem, isn't it?
Sorry, it's what? Sorry,
Yeah.
lower.
It's a much smaller problem. It says we know if we have a data control word, we know if we have an ACH, they can't coexist. We know if we have a file style PXD, it can't exist with either of those, and that's it.
No, that's one thing, but Kariti wants to do more. Kariti wants to make a decision based on the first Nibble, as I understand it.
Yes.
I understand they might do that, but for the time being, we are not there yet because there are so many things that need to be checked to do that. But what we have in the text.
So, Laura, just give me a second. So here's my proposal. We can write some text about compatibility of control word A with the FAI style label and control word B, and we can write that text that we were writing that you had written, and we can go with that, right? It's my suspicion that that text will have to get rewritten.
I agree with you, Kariti. As is now the text, I'm finding it hard for the working groups not attending the design call to parse. Yeah.
But I think it's more than parsing. I think it would come to a point where that text will be discarded. But here's my proposal: we go ahead and try to get that text in a form that people understand it, and people can to Tariq's point, they can parse it. They understand what it's intended, and they can go ahead and do. We actually go off and say, this is what happens with the first Nibble, and then answer the questions that Stuart is bringing up, and maybe to some extent Matthew as well. And I believe that when that is done, the original text will be superseded. But that's okay. Let's write that original text about what is compatible with what in a way that people can parse it, and people in other working groups that are maybe not following every step of the design team understand, at least in theory, what we're doing. And if it gets superseded, so be it. So we don't have to have this particular discussion right now, at least the one I'm trying to have. We write that text. I will go offline, write some different text, and then we'll reconcile the two. Does that make sense? I'm basically saying, Loa, go ahead with what you were doing, and I will come back next week and propose something else, and then we'll see how well they reconcile with each other.
Actually,
Why should I do something if I know that you are going to propose something else?
Exactly. I think there is a the reason we're having the discussion is there was supposed to be an email sent out, and the email is coming out from the MPLS Open Design team, and having this text in there. So if there will be new text, I think we have to hold off on things. Right.
All right. So then to Laura's point, if we can hold off for a week on sending out some text, then at the next next design team meeting, I will present my view of how this should happen. In the process of doing that, I will try to answer Matthew and Stuart's questions. And if it all holds up, we'll adopt that text. If it doesn't hold up, we will arrive at a version that does hold up. And if that doesn't work out at all, we'll fall back to Loa's text.
All right, that sounds like a plan. So we don't, we can't post this email yet. We haven't agreed it, but we have a plan to try and get closer to some text that we can agree on. So that seems a reasonable way forward.
That is fine. Having that said, I do not agree to the must not. I think that should be lowercase.
To where?
Can you go back?
Yeah, there is a must not here.
It's there, and it's also in the bullet before.
The original version was cannot.
Yeah.
And was changed. I changed it to must not. So if we agree, cannot might not be understood. What do you mean by cannot? Is it
why is that?
Is it optional or what? I mean, cannot. What do you mean?
No, it cannot. It cannot be there.
No, I mean,
but it's normal language. It's not requirement language.
No,
the design is. Do you mean the design is unable to support the simultaneous use of more than one set of PSD in a packet?
Yeah, actually,
it means it is not allowed to be.
Yes, strictly speaking,
it really should be must not.
No, bottom of the stack cannot be immediately. Just technically, it cannot happen, because if we are talking about immediately followed, then there will be only one
thing.
Is this a rule or a comment?
That thing can be followed by another thing. So the wording is confusing as is.
I agree.
Is the word a rule, or is the sentence a rule or a comment? Is it an observation?
I wrote it, but
is it intended to be just an observation or a comment on preceding text, or is it meant to be a rule in its own right?
There is a clarification statement after it. See if that helps.
If it's just a clarification statement, then must not is not needed.
No, I mean after this. There's a clarification statement after this. After. So there's a in bold is the statement, and then there's an IE after. So it's clarifying the previous.
Well, so I think it's either the design does not support them being there simultaneously, or two types of PSD must not follow the a packet must not contain two independent types of PSD.
Is that a capital must not in your language?
No, well, is it a comment on the? Well,
so I'm kind of objecting against using requirement language here. That's what I'm saying.
Right.
If you use must not, that's fine, instead of cannot. That's, oh.
But what is it you're asking the working group to give you feedback on then? I mean, when they see must not, how do I interpret it as a implementer? Like I get confused. There's confusing language in there, honestly. And I'll tell you that if post-stack data, does it mean that user data is there or no? Is inside post-stack data?
Post-stack data is there because something in the stack tells you that it's there. If there is nothing that tells you that there's post-stack data, it's not there.
No, I mean, when you say post-stack data, is it only ASH, FAI style PSD, or post-stack data encompasses user data as well, right? Just linguistically, from English language, post-stack
well,
data.
then I'm disqualified. I don't understand English really.
Oh, I see. I mean, I'm not going to claim that I am.
I think what you mean here is that some embodiment of some data that can be used by the network, rather than, you're not talking about any old data which may or may not be used. You mean actually something that we're pointing to. So
Exactly, Matthew. Assume I'm not attending the design team every week, and I see post-stack data. Do I assume anything as after the post-stack? What does it mean?
Yeah, I think we need to define what we mean here, because we're not talking about payload. We're talking about, you're not talking about user payload. We're talking about some encoding that we can use for doing something in, that the MPLS network can do something with.
Literally, post-stack data means the data that comes after the stack. So
yeah, so I think PSD is the wrong term here.
Hold on a sec. What we do have is the first nibble. And so this is the direction where I'm trying to take the first nibble registry, is you look at that first nibble, and if that first nibble is 4 or 6, we try to get to a place where it always means that this is an IPv4 or an IPv6 header. If that nibble is not 4 or 6, that means it is a header that you interpret it, and the way you interpret it depends on what that value is. And then that post-stack data turns into post-stack data that we were thinking of. The 4 and 6 usually would be, this is actually payload, but you can occasionally get confused because it was actually an OUI of an Ethernet address, which happened to have a first nibble of 4 or 6. If you ignore that sort of exception, then the post-stack data, interpreting the post-stack data is based on the first nibble. And I know what Stuart's objection here would be. What is in the wild is in the wild, and there will be that payload which starts with a 4 or 6, which you might interpret as IPv4. That's what's happening, and that's not something you can change. You can't take those implementations, well, until you take those implementations out of the network. But going forward, you are not going to introduce any more ambiguities. Going forward, if it is not an IPv4 or an IPv6 packet, you must put a non-4, non-6 post-stack header so that there will not be any confusion. That's pretty much.
Yeah, but I think
there are other ways of reducing the confusion. That is to say, a new packet must have some other qualifier before we're allowed to look at the 4 or 6. Sorry, Matthew, you had a point.
Yeah, I think the point of this restriction here was just to say we don't use, for example, we don't use the GAL on the same. There's not a GAL GACH construct on the same in the same packet as an FAI style SPL.
Yeah, so
that's what we're trying to say, right? Not anything more than that.
Right, exactly. So I completely agree with you. And this is why I said, if we write this as we do today, and then we come back in a week or two and settle out, what the first nibble is about, we can come back and say, by the way, when the label stack ends, the situation we would like to see is, if the first nibble is a 4 or a 6, it's an IPv4 packet all the time with new implementations. I'm not talking about legacy. If the situation is a 0, it's either the DetNet control word or a pseudowire control word. If the first nibble is a 1, it's something. If it is a 5, it's beer. And if you want the new FAI style post-stack data, we pick a number that's not any of those. So we might pick 7, we might pick 13, we might pick 3, I don't know if 3 has been used. And so what we're trying to say here gets said immediately, because the first nibble is either a 0, which in case some gal ACH or something, or it's a 13, in which case it's FAI style. So you don't have to say it because it's implicit in the first nibble registry. You go look at the first nibble, it says new style, FAI style post-stack data, or it's an IPv4 packet, or it's so it lays out exactly what it is.
Yeah, that's fine, because that basically is just, but that's really saying only look at the first nibble on the stack. Don't ever have a situation, for example, where you have, I don't know, two GACHs below the stack.
Yes, yeah.
Two different kinds. So you're let's say packing LSP ping and BFD into the same packet somehow, something like that. So what we're saying is that the first post stack word is definitive.
Yes, exactly.
But it's not.
It's not.
Well, so like I said, that's where I'm trying to go. What I'm going to do is write it up, hopefully clarify, all of these corner cases that Stuart, Matthew, and you are bringing up. And then we can arm wrestle and say, yeah, this is fairly complete, or wait, there's still some more holes, or maybe it's fundamentally flawed and we have to go back to a different way of doing things. But if we can get there where we can just look at the first nibble, then I think we'll be in a place where we're good.
Oh,
that's the goal.
can I say something?
Yeah.
I think we should never try to use the first nibble as any protocol indicator. If we have our defined definition of the post-stack data, we should already have something in the label stack to indicate that, so we know for sure what will follow. We should never rely on another nibble to indicate that. In history, there's no any indicator in the label stacks, and that's why sometimes we have to try to use that nibble, or if it's IPv4 or v6, we don't want to confuse. In our new design, I don't think we should continue to follow that, because now we have new mechanism in label stack to tell us explicitly what we expect. So I don't think that's a reliable way or ideal way to do. And at most we should ignore that label in our new design, but we shouldn't rely on that.
So I disagree with you, and from what I see, we are making more use of the nibble. I want to use that nibble to its logical end. And by the way, it's not. Can I finish?
Yeah.
It's not a protocol indicator. What it is a dual purpose thing. For the specific values of 4 and 6, it indicates, not with full certainty, but with high probability, the packet you're dealing with is an IPv4 or an IPv6 packet. For every other value, it indicates this is what the header is, not the packet. This is what the header is. And this is how you interpret the contents of the header. And after that, what you do with the packet, you need to figure out some other way.
Yeah, you just
Post
said
that-
even its value 4 and 6 is not a reliable way to tell what it actually is. So we should never rely on that. That will, if we do that, that will make mistake.
There is
Or make any indicator in the label stack redundant. You know, so if we have something in the label stack, why do we need to use this?
We don't have something in the label stack for legacy applications anyway. So I don't know where this magic comes from. Whether it's in the first nibble or in the label stack, the original router that created this packet has had to behave in a certain way. If everyone behaved perfectly, we wouldn't be having this conversation. The problem is a lot of this was done by accretion, done by, hey, I could do this, there are a few heuristics thrown in. We have to deal with those routers. But what we can do is say, going forward, we will have fewer of those problems. And eventually, when those routers that don't conform go away from the network, we have a situation where everyone understands everything perfectly.
I think if we do have our new indicator and the new post stack data in the packets, the legacy router cannot handle that anyway. So we don't expect we can still run this in the old routers. We have to update those, all the, at least all the edge routers to support this, to support our new package format, right?
Sorry.
So I don't think we have to. I think we have to learn how to live with legacy. Do no worse.
And even you honor those 4 Nibble, you can still not achieve your goal to make it work in the old router, because you have something, that's cannot be recognized by the old router at all if you have some indicator in the label stack.
So if you let me finish, I'll tell you what I'm trying to get to. I'm not trying to get the old routers to understand the new stuff. That's not going to happen. What I'm trying to get to is the old router's behavior doesn't have to be changed. We don't have to update all the old routers. The behavior that they have is flawed. It'll be probably flawed in the new style as well, but hopefully less so, less often. But I think we have to be very clear what you can do in the network while the legacy routers are still around.
Kiriti and Huayu and team, I did capture that the team is agreeing that the design directive text will need to be revised. Kiriti, you're volunteering to propose some new revised text, and the team will review that. For the email, we're holding off from sending it for now until we review the new text or fall back on the old text. We have other items on the agenda, and I do want give a chance for the other items to be visited, at least to be visited. So I'll give you a chance to say the last words, Kiriti and Huayu.
I have nothing more to say. I mean, I'll produce the text, and I think one thing I will say is that it might be helpful if someone thinks that they can take the current text, because there are these discussions about cannot and must not, and are you being prescriptive or are you being descriptive? The current text, moving it forward a little bit, it might be work that's throwaway, but I think it's useful as a backup plan. So if someone wants to do that, they can do that. But on my thing, I will produce text, and then we'll have something solid we can argue over next time.
Thank you. Huayu, do you want to go next?
No, let's see what Kiriti will propose, and then we'll start from there.
Okay, thank you. Loa, I'll give you a chance to disagree or agree on the resolution.
I think we are confusing things, but yeah, let's try to solve it next time.
All right. I'll go back to the agenda then. The next action item was the first Nibble registry. Coincidentally, this is what we're talking about. Do you want to talk about the draft update, Kriti, besides the discussion we had? Anything you want to, Kriti?
Yeah.
And that, right?
I can give a quick overview if you have time.
Yeah, I mean, it's on the agenda, so.
Yeah. So the draft, the general idea of the draft was to say, how do people use the first Nibble today? So essentially, they look for the 4 and the 6, and if they see a 4 or 6, they say, "Oh, I think it's an IPv4 packet or IPv6 packet." They find appropriate fields and do load balancing, or they find it's not 4 or 6, and then they say it's not an IPv4 packet, and then it's kind of, oh, if there's a 0, then maybe it's a pseudo control word. And all of those things are a little bit subject to problems because an Ethernet, a bare Ethernet packet that comes right after the label stack could confuse things. So the first Nibble registry has sort of 3 purposes. One is to say, why did we do this? What do we do? How are we doing it? What are the heuristics that are applied? What are the issues with that? The second is to say, we mandate that there should be a post-stack header, which means a Nibble value of not 4 or not 6 for any case where that payload is not IPv4 or IPv6. You could go further and say, I don't care. There's always going to be a post-stack header, and then you parse the post-stack header, control word, whatever else you need to do, and then when the post-stack header is over, then you say, okay, now my real payload starts. And at this point, I don't know what it is, but I'm not going to mess with things there. So to go back, I want to, to write down what it is that we do today and why, and some of the rationale. What is it that we should be doing? And in order to, make everything easier to do, to have a registry that requires an standard stack RFC to put, so to gather the existing values that are allowed for the first Nibble, and then create a registry that says, if you want to create new entries, it must be a standard stack process, standards action process.
Kriti, is there a new draft already?
There is not a posted draft. There is a draft that we're circulating that I was supposed to put on GitHub. I haven't done that yet. I will try to see if I can do it today. If not, I will ask you for help on adding things to the GitHub repo, and so it will be sort of a public draft that people can see, if they go to the GitHub repo. But over the course of the next couple of weeks, I want to get it out as an actual draft so that this can be officially discussed in IETF 112.
Thank you. Yeah, is there an ask from the design team after you post the GitHub, the draft on GitHub? Do you want the design team to review it?
Yes.
Okay. Thank you.
So before next Thursday, I will put up this on GitHub and send a pointer. Hopefully, well before next Thursday, so people can see it. Because showing it, displaying it, on the screen, sharing it via WebEx is pretty painful. So if it's available, people can read it. People can go back and forth, and then I think our discussion will be more meaningful. So it's my task to update it and to put it on GitHub between now and next time.
Okay, thank you. Any questions to Kriti on this item? Okay. We'll move to this next item, which is, required us to revisit it last time. There was an ask to schedule a meeting with the .NET working group to discuss again the MEAD and the existence of the .NET control word and any possible OEM. I think we're circling back to this point. Are we ready to have that meeting with the .NET working group or chairs? Or should we defer that?
I simply don't know. I don't know where I am just now.
In Stockholm.
Yeah.
Just a wild guess there, but no, I just want to update the action item. Are we comfortable to schedule a meeting?
I think we need to defer this until we actually decide on what we discuss next week.
I agree.
Okay. We just submit this. Oh, okay. It's garbled. The next item on the agenda is a update to the status report. I don't have a significant update to report since last week. I'm still shooting for a first draft revision before IETF 112. That's my update on this status report. Any questions for me? Okay. The next item on the agenda is the update on the requirements spec. Matthew, I know that there's a link there, so you want to talk about it?
Okay, so I created a wiki page for the requirements, and there is also we also just uploaded a first stab at a draft with help from Stuart to start documenting some of the ADI requirements, ancillary data indicator requirements. It's was only posted about 2 hours ago, 2 or 3 hours ago. So anyway, that link is to the draft. So any feedback on the draft would be great. So basically, the draft, just if you click on that, it'll take you to the draft. Yeah. So at the moment, it's just a set of sort of some background and some general high level requirements to steer the protocol design work.
Okay. I have a question to you, Matthew. How would you like to collect feedback?
Either
Email,
mail on the list, mail to me or Stuart, and also, I mean, possibly it might be worth. I'm wondering if we can use the wiki somehow to for comments from during these meetings. We can maybe put some notes on the wiki, and then I can transfer them into the draft.
Okay. I also have a option of putting this up on GitHub so that people can comment, like give review inline.
Sure. Yeah.
If you like that.
Yes. Yeah.
I can help. No problem.
Thank you.
Okay. Anything else you want to add on this? And anyone else wants to ask about this?
I just made a note when I saw the wiki page coming up, and it's at that time it looked like it was use case only. And what I'm saying is that I think there are a number of requirements a fairly low number of requirements that we can't actually find out from the use cases. It's more of a general kind. It's things like keeping the MPLS architecture viable for the future. I don't think we can get that out of the use cases. I haven't looked at what Matthew talked about as general requirements in the current draft. I will do that. It's possible that it's covered.
Yeah, we have tried to take on board some of that. Obviously, you know, it's not just extracting requirements specifically from the use cases, it's also setting some general principles. For example, the one that you've written on the wiki page there.
Yeah, okay.
Okay, thank you.
I think
Matthew.
the right thing to do is to request that people read it and then just come back and discuss it.
Yeah, and I have to apologize. I just looked at it and I can't spell ancillary, so I will fix that in the next version.
You can use helpful.
I'm sure that Matthew will spell ancillary right.
No, I didn't go through and correct it in all the places. I have too many eyes.
Don't worry. Don't worry. Don't worry.
Okay. Thank you, Matthew, and I'll move on. The next item we have on the agenda is a proposal from John. Let me put it up on the screen, and I'll give him a chance to talk about it. Hoping you're still there. You are silent and.
I'm here.
Okay, go ahead, John.
Okay. I don't think I'll read it, but have people actually looked at it?
Yes.
I have reviewed, yeah.
You know, because what I'm wondering about is maybe I should just answer questions if people have questions about it.
I think, John, it's best that you know, although people might have read it,
Okay, I
you
can
know,
go
talk
through it
about
then.
it.
Yeah.
Yeah. To give it, you know, yeah, a fair chance to.
All right. Well, anyway, what it's trying to do is complete and extend the FAI work. It's basically just to try and clean it up. And because I sent an email to Loa yesterday, sort of enumerating the functions that we've been talking about that have been proposed over the last 6 months or so. And some of them are related to forwarding, others are not really related to forwarding. So I was using the term network function rather than forwarding action. The key point, I think, is really in the second paragraph, which is when we're defining a function, we're basically going to define it via an RFC. We're going to define what the function is, whether it needs ancillary data, if it needs ancillary data, what that ancillary data looks like, and we're going to describe whether it's in stack or after stack. And we're going to assign it a particular bit in the bit vector, which is carried in the, whatever it's called, the network function label stack block. So that, which is then getting into the third paragraph, which is that we have two special purpose labels, one for end-to-end, the other for hop by hop. And this was a suggestion from Stuart and Adrian that it allows the end-to-end functions and the hop by hop functions to evolve separately. And it allows the P routers to only look at the stuff that they care about. They don't have to worry about the end-to-end stuff at all. And so then we'll have a special purpose label for end-to-end and one for hop by hop. That's followed by and we're going to leave the fields that are not special purpose label as they are today, because we really don't want to, we don't really need to do anything with them. So then following that is a set of one or more 30-bit fields, which are basically the bit vectors, which are defined as we the bit vectors need to be defined contiguously. And so when we define a new function, we'll just take the next available bit in the bit vector. And so then there's a set of one or more 30-bit bit vectors, which are basically just contiguous. And then that's followed by label stack entries, which carry the label stack, the ancillary data for that is to be carried in the label stack as opposed to post stack. So then when a P router gets a packet, it will identify that it's a hop by hop function. It will look at the bit vectors and understand which ones are set in the packet. And basically then that will give it a map for, and the ancillary data, both in the label stack and post label stack, is set in the same order as the bit vectors. So depending upon which bits are set, you know exactly how the ancillary data in the label stack looks and which piece is for which of the specified functions, and the same with the after stack data. And I think that's about it.
Thank you, John.
There's one other thing, which is the looking at incremental deployment. What we're saying is that at any point in time, a given P router will only understand a particular set of network functions. And he doesn't have to support all of them, but he understands all of the network functions up to a certain point in the bit vector. And so it will process the packet up to the point at which he understands. And at that point, he considers the rest of the data to be opaque and just skips it. So that we can incrementally add network functions, and the P routers that don't understand it will just ignore it.
Any questions to John? I have a comment, not the question. I think the proposal of having two special purpose labels, one for hop by hop, one for end to end, is an interesting proposal. It at least reduces the function or action vector or registry by half the size of it. Yeah, I mean that's one value, and I'm not sure what is the feedback, but I should mention that indeed lots of what you're proposing is what the design team has been looking into. So it has.
Okay, I mean, this is what actually happened was I had been putting bits and pieces of this out in comments to the mailing list. And I just thought, rather than continuing to put it out piecemeal, I ought to just consolidate everything into one place so that we could see what it looked like.
I have some comments. My understanding is that you actually try to put a catalog of headers after for the post stack data in the label stack. But as I have talked last time, I actually, you know, this kind of catalog is has very little or no help to the actual chip forwarding performance. The reason is follows, because in the modern forwarding chips, it always pass all the headers first. And once they see this header, they already know its type. So there's no use to just give a catalog somewhere in the packet to tell what you have, because you will need to pass the header anyway. Then when you get the headers, you already know what you have or what you haven't. So that's why we should really try not to add an indicator to tell, okay, what functions we have after the label stack. That's doesn't help.
Well, we need, we need to understand the structure of the ancillary data in the label stack itself. For
Yeah.
the post stack data,
We do, but
the post stack data is going to be self-identifying.
yes,
However, if you do put it in the order that's in the bit vectors, then you may get a performance boost
no.
because let me finish.
That answer is no, because the only requirement I think is we should always put.
Are you interrupting me? Are you interrupting me?
Okay, go ahead.
Let's give a chance for you to John to finish, and then go ahead, John.
Yeah, no, the post stack data. The only reason really to put it in the order that it's in the network functions bit vectors is that you may get a performance increase because you're doing prefetching. In other words, you're going to pull in the data for network function N, post stack data for network function N, and as part of that memory fetch, you may bring in the post stack data for N+1, N+2, N+3.
So, John, just to check if I understand. Wait, I have a question for clarification. Are you saying that we need to put flags in the flag field for every post stack data we actually put after the stack?
Yes. In other words, when you're defining a network function, it's going to be defined in an RFC. We're going to define what the function is. We're going to define whether it needs ancillary data. If it needs ancillary data, what does the data look like? And is the data carried in the stack or after the stack? And then what we're saying is that you use the bit, you basically are going to set in a particular packet, you're going to set certain network function bits in the network function flags fields. And then the ancillary data, both in the stack and post stack, is in the same order as the bit flags are set.
So,
Okay.
does that mean that if you have the first flag is, I actually have two different SPLs also?
That's exactly what I mean. Is this kind of catalog is useless because the only information we need is that up to a point, if we still need to continue to parse a packet or not. If we have that kind of information, that's enough. That's why we do need an indicator to tell what follows the label stack. If there's something follows, we need to continue to parse a packet. So that's information.
Yeah, and
that information is enough. We don't need to know what actually we have because we need to parse that header anyway. After we parse the header, we know what we have because every following chip will do the parsing first, then do the processing next. So after parsing, we know what we have and what we need to process. Then in the second step, we do the corresponding processing. So you can see the catalog has no use to boost the performance.
Well, actually, the way it works is that the individual network function bits tell you whether you have post-stack data or not. In other words, we don't have a separate field which says there's post-stack data. It's implicit in the definition of the network function.
We have a label, right? We have a special label or a bit.
How are you? And John, I have a clarification. Is when you say why you parse the post-stack data, is there an assumption that it's a TLV, like there is a type there inside the inside the data? So when you parse,
we already, if you look at our extension header proposal, we just have a header change like the IPv6 extension header. So we just do the parsing, follow this header chain, then we get all the header we need.
So my point is why you is if the type is already in the flag that John is talking about, so that tells you that the first length value, there's no type length value in the PSD, there's only length value, and the type is from the flag. So you get the type and the order of the LVs from the flags. Maybe that's what he's hinting to. There's no redundancy. Basically, the type is not present in the PSD.
Well, no, actually,
Well, then,
what you can I answer?
yeah.
Okay. What Tarek said is true. However, I was assuming that the post-stack data was also self-identifying. That's in the second or third from the bottom of the write-up before it says if NFF3 and or NFF6 were set, then it knows to look for bottom of stack data. The paragraph after that.
Oh, here, okay.
It begins if NFF and NFF6 were set, then it knows that there's bottom of stack data. And if NFF3 was set, then if only 3 was set, then the first piece of data is going to be for 3. And it will say this is for 3, just for sanity checking.
So, John, there is an argument that if there is a type length value, then it becomes redundant to have, if I'm parsing all of this after the stack, then why am I?
Yeah, I understand. The only reason to do this was for consistency with what we have to do in the label stack. In the label stack, we need to know what the ancillary data looks like so that we can.
We don't need, that's the point. We don't need to know that because that's redundant.
I'm talking about in the stack.
Yeah.
In the stack, we have to know what the block looks like.
Why?
Because otherwise you don't have any way to interpret what the individual label stack entries mean.
Why? Because that's exactly how parser works. If I know in the stack, I know, okay, I need to continue to examine the data after the label stack. Then I will continue to follow that. Yep.
I'm not talking about after the stack. What I'm saying is that we need to understand how the ancillary data is structured within the label stack. And all I was saying was there's no reason to do it differently for post-stack. There may be some performance improvements that be had by being able to pull the data in.
Same thing. Even in the label stack, we need to, unless some label we will define as a function, it's just a normal label. If it's that special label, we also know what it is. So that really depends on how we will go forward. If all the in-stack data will be special labels, we will know after we scan the label stack, we will know what they are. We don't need the catalog for that either.
There's one special purpose label for many network functions.
I agree with John here. This is what the design team has been talking about.
If you want to use a single label to indicate the functions, all the function already be embedded in this single label, then okay, that basically that bit is tell you what the function is. But I mean, if you have some other special labels as functions, follow this this one, then we don't need to tell it in that previous label.
The whole point is that we don't want to have a special purpose label for every separate network function. We want to put
yeah, that's fine. That's fine. That's just for that special aggregation label. That's fine. But I mean, for other label follows, you don't need to tell there are such kind of labels somewhere before it.
Right. And so what I said was we need to be able to understand how the ancillary data is encoded within the label stack block. There is no reason to encode it in a different order in the post-stack data. That's the only statement I'm making.
So, John, if you have two special purpose labels with two different flag fields, one for end-to-end and one for hop by hop, you will have two sets of
bottom of
Or-
stack data.
So you have one set after the first special purpose labels and another one after the second, and they can each be end to end, or no, sorry, they can each be in stack data or post stack data.
Correct. And what I said was, we want the hop by hop network functions to precede the end-to-end functions within the label stack, so that the P router just looks at the first thing it sees, and that's all it needs to do. For the post stack data, or whatever we want to call it, the ancillary data for the hop by hop functions is first. The ancillary data for the end-to-end functions is after, for the same reason.
And this, yeah, that's not much, because for the in-stack data, they are just following the SPL.
Yes. In other words, in the format of the label stack block is a special purpose label, a set of one or more bit vector fields, and then the ancillary data for each function that requires, for each function whose bit is set in the bit vector, which requires ancillary data. And the order in the stack is the same order as the bits are set in the bit vectors.
And that's also true for the PSD.
I'm saying you might as well. There's no reason to just, make it arbitrary. And the other thing I did note, there may be a performance advantage to having it in order, because as you're doing the memory fetches, you can be effectively doing prefetching.
You're saying, I know the first 4 of potential 6, so I only need to look at the 4.
Right.
If you look at in the real hardware, there's no concept of a fetching or prefetching. It's just have a packet header buffer in range. Then you just do the parsing first.
Can you state definitively that every piece of hardware that's been developed and will be developed always parses the stuff first?
Yeah, I'm addressing all the May flow, mainstream chips available today.
This is factually not correct, in fact. And if OpenFlow is not the only forwarding paradigm in deployment.
No, saying OpenFlow, I'm already telling the mainstream chips from both Broadcom and Intel. No,
That's fine. There are far more software-based forwarders, and if you look into the forecast of how the industry will develop,
same thing. I also understand all the major network processors. Those are software.
If we are talking about anything general programming, they all rely on prefetching. If you want any performance, prefetch is mandatory.
They have the packet buffer to either it's a few hundred bytes maybe, or just slightly more than 100 bytes. You can work on those bytes. It's already in the buffer. You can do anything about it. If you request more than that, then you need to fetch more. Then that will reduce the performance. But that's what we call the header buffer. So that's a critical design requirements. We need to. That's why we need to reduce the header overhead, but not this kind of the header design with this kind of catalog doesn't help, because it doesn't help you reduce the header overhead.
I think what I would like to recommend, Loa, is that at the point that we actually have a proposal for doing this stuff, that we actually validate it with as many different hardware specialists as we can find.
Yeah,
I mean,
We
I
can
don't
say
think
that,
that we
but my experience is that doing that from an IETF platform is hard.
no. Well, what we can do is we can just, as part of the process, we should make sure that the vendors who are on the design team verify with their hardware associates that the hardware associates think the proposal is doable.
Yeah, okay, that's probably doable.
You know, because I think that the more input we get on the hardware ramifications of any proposal, the better off we'll be.
Tarek, did you capture this
Let me do
part
that.
of the note?
It's a good point, actually, John. Yeah.
Yes, you know, like I said, Tarek, I've been putting pieces of this out over time, so all I really wanted to do was get everything down in one place.
So if I understand you correctly, the major difference is that you actually have two different flag fields in two different SPLs. You have two sets of PSD, and then you have instack data just following the SPL. The thing with the PHY proposal is that there is only one bit pointing to that there is PSD, and then we haven't decided on the order, but we could do that.
Well, actually, Law, the point I was making is that you don't need an explicit bit to say there's bottom of stack data, because associated with the definition of any network function is where its ancillary data, if needed, is to are indicating bottom of stack if any of the network function bits are set which require bottom of stack data. So you don't need a bit to say there's bottom of stack data. Of the
I kind of.
Hi, John.
Yeah.
I have a question here. You're talking about the hop by hop and the end-to-end functions with the data in the label stack. Then how about the functions which require data to be in the post stack?
I thought that, yeah, I mean, what happens is that for every network function bit, we describe whether it needs ancillary data, what the ancillary data looks like, and where the ancillary data is to be placed, either in the stack or after the stack.
Yes, and I noticed that sentence that mentions that if a given network function is directly related to forwarding and requires ancillary data, and data should be placed in RSEs.
That's,
I mean,
it's not strictly necessary. I mean, you can do it either way, but if you're doing a forwarding function, it's probably best to have the ancillary data where you can get your hands on it quickly.
yeah,
but it's not.
I understand that.
You know, you could have an end-to-end function that has ancillary data, or I'm sorry, a non-forwarding function which has ancillary data in a stack. And you could have a network function that's related to forwarding whose ancillary data is bottom of stack. It's just that, generally speaking, if it's related to forwarding, you want it to be close at hand.
Yeah, so you mean that it is preferred to be close to the top of the header, right?
Yes. Yeah.
But maybe there's some limitation about the space in the label stack entry, like if you have one.
Sure. And there's nothing, I mean,
more.
What we're going to do when we define a particular network function, we're going to define where we want the data to be.
Yeah.
The other thing is that in a given packet, even if we've defined 62, we have two label stack entries of bit vectors. So we've defined whatever it is, 62 different network functions. In any given packet, there's probably only going to be 1 or 2 or maybe 3 network functions that are required.
What I mean is, if you have some data which is exceed the size of a label stack entry, maybe be more flexible, or
apologies, I need to drop.
Yeah,
we
we actually closed the end of.
We are close to closing the meeting also.
Okay. The ancillary data. Yeah, I was just going to answer that one question, Law. The ancillary data for a given network function can take 1 or more label stack entries.
Yeah, I understand. And there's still the bottom stack bit inside that.
Yeah, and like I said,
be a continuous field to carry some data in the stack if it is larger than one entry size.
You'd have 2 label stack entries. You could even split a label stack entry among multiple network functions if you wanted, if the ancillary data was not large.
Yeah, that is a possible approach. Yeah. We can discuss.
This is really just a framework for defining network functions.
Okay. Thanks.
It doesn't define any network functions. It just says when we define the network functions, this is how we want to encode the information about them.
Yeah, I understand. Just want to make sure that it covers both cases, label stack and the post label stack.
Yeah, well, I mean, like I said, it's explicit in the definition of the individual network function.
Okay.
John and Jimmy, I have to stop the recording.
That's fine.
Okay.
Okay.
Okay. Later.